Hello, Nevada County. This is David Clark Carroll with the Nevada County Tech Connection. We're an initiative of the Nevada County Economic Resource Council, and we're tasked with looking at the intersection of business, technology, education. Really, every possible aspect of life is touched by tech these days. We're joined today by, he told me, and I might get this wrong, so my apologies, Franz Veitschegger.
Perfect. Beautiful. That's
Uh,
perfect.
all right, I did it. Really pleased to have you on today. This has kind of been a lengthy process to talk to someone from the Advanced Manufacturing Program, which is a program that teaches skills we need in Nevada County. One of the things we always hear from manufacturers, from small businesses, is they can't find qualified people. But fortunately, we're real close to a place that will teach you how to do that. In the past, we've had folks on from the mechatronics program, from the cybersecurity program, and we're talking to Franz today because I wanted to talk a little higher level, look at the various things that are within the program. And it all started because CNC fascinates me. So I know you guys teach that. And then when I got into this, I realized how far the tech has advanced. So what other kind of computerized manufacturing things are taught there besides CNC?
Within my program,
Yeah.
so it all kind of revolves around CNC, computer numerically controlled machines, and we do. So our primary focus is
Yeah.
kind of machine shop related, but we also have, I don't like to call it a sheet metal class, but it's where you do your two-dimensional design, so in a flat pattern, and you cut it out on either a laser, water jet, plasma cutter, and then form it through bending processes into a three-dimensional shape. So we have that, and we have a bunch of projects associated with that as well. But the core, and then we have mechanical drawing classes. We absorbed, there was another department called DES, it's Design Engineering Support, where it's really revolves around ASME compliant drawings in architectural and mechanical. And we have absorbed the mechanical side of that. So we are teaching those classes as well. I am not, I'm on the machine shop side, but we have those under our umbrella. Um, yeah, and we have an AS degree, a skill certificate, and a certificate of achievement in advanced manufacturing.
I mean, it was just digging through the various paths that students can take. It's, if you're looking to work in an industry that pays well, offers security, because again, we have a shortage of these jobs. This is a great way to get into the field. Um, Now, we're gonna rewind a little bit here because part of what's always fascinating about these tectonics is we're talking to people, you're advanced in your field. You've reached the point where you can show other people how to do this. And we always like to be like, how did you get to that point? Like what was your career path? Because sometimes people tell me surprising things sometimes, and it's always cool to see how you got to where you are.
Yeah, my career path has not been a straight trajectory at all. Yeah, if you just looked at like what I did, you'd be like, what is this guy doing here? I mean, actually, it kind of makes sense. So my dad, yeah, my dad first got a welder for me when I was about 14 or 15. And then so in high school, I went to Folsom High School and we didn't have a metal shop. And when I was about a junior, I was junior or senior, and to take a metal shop class, we had to go to a continuation school in Rancho Cordova, which was Kenny High. And Rich Smith was my instructor there. I still talk to him to this day, not a ton, but I see him every now and again. So we'd go over there for metal shop. And then at that metal shop, I got a job working at Strapini's when I was in high school. And so I worked there on and off during high school. I worked as a bike mechanic at Bob's Cycle Center, and I've always like ridden bikes and kind of been into that mechanical aspect of things. My problem when I was younger, I enjoyed riding bikes more than I enjoyed studying. When my parents were like, "You're gonna go to college, buddy," so I was like, "Okay." Um, and then let's see. So in college, I still continue doing fabricating. I actually sold my own components. I had it in a diesel truck magazine. So in college, I kind of made my own parts, sold them, and that was a lot of fabrication, welding, and I'd get my parts machined. And I eventually bought my own machine. I worked on a race car crew team too, and I worked at a race car, like a race shop where they build tube chassis race cars. And we travel the West Coast. We'd be in Idaho, Medford, Oregon, and just kind of racing on the West Coast. And let's see. And then so in college, I floated around at actually Sierra a lot because like I didn't know what I wanted to do. I was just concerned with having fun, which was, now that I look back, I'm like, dang, like basically 10 years behind everyone else. But I eventually, I was like, you know what? I want to own my own business. So I'm going to do business with a concentration in accounting. And while I was at Sierra College, I got I don't know whether it's, I think it's AS in welding. I got an AS in natural science, business technology, and natural science. I think I have 4 ASs from Sierra College. So I didn't completely waste any. Yeah. This bores me, on to the next. Anyways, so I did business. I was like, oh, with a concentration in accounting, I was like, okay, this is like easy math. Okay. And then I went to Sac State. I was business with a concentration in accounting. And during that, I also interned at an accounting firm, and it just, that wasn't for me. I didn't really enjoy that kind of stuff. So then when I graduated from college, I worked for the Strapini Enterprises again for a couple of years. While I was there, I did a lot of sheet metal stuff. So bending, we had a multi-access high definition plasma cutter. And it's like high end. I think the machine itself without an air handler is like 250 grand. And then we had robotic welders, a whole machine shop on the other side, running machines, that kind of thing. I did that for about 2 years, and I finally was like, you know what? I want a desk job. So I thought, and so I was like, I'm going to utilize my degree, and I got a job doing diesel fuel tax auditing for the state of California. So now everyone hates you because you're an auditor, but it's really just making sure they're not overpaying or underpaying like their tax liability. And while I was doing that, I'd always go back and forth to Sierra and talk to the former chair of the department at like I wasn't, no intention of getting a job there at all, but I always talked to the former chair, as Bill Wenzel, just cool guy, liked to be at the shop, and they didn't have any machining at the time. And so one day he goes, hey, you want a part-time job? And I was like, okay. So I taught on the welding side for about 2.5 years, and I saw him building this program, and I still had my full-time job. And so I was like, I was kind of getting sick of doing the 2 job thing. And then Bill was super good encouraging me. He's like, yeah, just, hang in there, like whatever. And I was like, okay. And I saw this program was opening. So I was like, that would be a really cool position, because I probably failed to mention this too. At the time, I had my own CNC mill. It was at my parents' house at the time. I had my own, it was a manual lathe. I had like kind of my own workshop, and I'd make my own stuff. I'd tinker around, build things. And so like, I'm not, like I worked in a machine shop too. So like, I'm still doing all this stuff on the side. And then had a bunch of adjunct instructors, and I was like, you know what, I'm going to apply for this job. So I'm going to take the class and actually see how the class runs, see what kind of projects they're doing, see what works well, what doesn't work well. So I enrolled as a student. And when you're a teacher there, you can actually audit a class and just sit in on it. But I enrolled, I paid, I did it as a student. I went through it. And before that, I never used a Haas machine before. So I also wanted to kind of see how that works. And then I took the class, I kept working there, I applied for the position, and I got the position, quit my other job. And here we are. I'm sure I missed a bunch of small stuff, but that's kind of it.
But it's just a great example of something I've observed in my life and elsewhere. It's so many of us try all these different things over the years, and then some point you find yourself doing what you did when you were 12 and loving it. It's like,
yeah,
could have just kept doing that my whole life. Oh well. But we wouldn't be the interesting people we are if we don't go through that journey to find out that actually we have a pretty good idea of what we like when we were early kid.
Yeah, I never thought I was going to be a teacher. That was never on my radar. I was never talking to Bill to like be an instructor. That never crossed my mind. And in fact, my job, because I was new to that auditing job, when the first semester I tried to work there, my job turned me down because they wouldn't let me adjust my hours to work like this Friday class that was offered to me. So the first semester I couldn't even do it. And then he asked me again the following semester, and I could work it out with my other full-time job at the time and then do it. So yeah, I had no plans on being a teacher.
Well, and I think that's one of the fascinating thing about Sierra College. Almost everyone I talked to, they they had a whole career before they got to Sierra. You know, they generally were working in the field. Like when I talked to Alex Torres, you know, he didn't teach computers his whole life. He worked for HP. He was, you know, out there in the world. You're out there, you know, fabricating stuff in various worlds, doing accounting too, which, you know, I like how you, at the end of the day, you wound up, you got the perfect hybrid. You've got a desk job where you get to work with machines. Kind of awesome. So
Yeah.
it's also yet another one of the, hey, you went to Sierra and now you're working there. So if you're watching this thinking about, should I go to Sierra? Well, it might help you to get a job at Sierra. You never know.
Yeah.
Okay, so that's kind of an awesome, you almost, I couldn't have asked for a windier path. And that's what I love. I love talking to people who are like, oh, yeah, no, this was, I tried a bunch of different things. So again, if you're the classic Nevada County person out there looking to switch careers, hey, you're not alone. And Sierra's got your back. So, you know, now that we know where you're coming from and, you know, what sounds like a pretty extensive lifetime of working with fabricating metal and various things like that, what does it look like, you know, in a classroom that student comes, you know, to that first day? They, you know, maybe their parents saw this podcast, maybe, you know, they heard about the program from a family friend who needs an employee, but they signed up and they showed up and they don't know what they're expecting. How's that first week of class like?
So the very first day I will have the students on the machines. I make sure they sign their, what is it? It's a form to make sure they can't sue us. It's escaping me right now. But anyway, so with COVID, it was kind of course, it's bad, but it kind of actually it channeled this new way we teach because we were on ground the whole time, but we were doing this hybrid format. So a lot of what we do, it starts on the computer. It starts with a 3D model. It starts with creating all the tool paths on the computer. We use Fusion 360. And then, so I do all those assignments and they have the entire week to work on it. So they only have to come to lab one day a week, which works really well for a lot of our students who have full-time jobs. And so when they get to lab, they're there to set up the machines and run their parts based off of their programs with my instructions. And so the first week gosh, wrists gosh, I cannot think of why is this whatever. So they come in, I go over the spiel, I go over our documents, like the important stuff, how my structure is laid out, how to navigate my online information. So when you sign up for Sierra College, you now have a Canvas account, and that's kind of like our cloud storage where our class is and where I store all my information. And I explain to students how to do that. And then in class, I get them on that machine. We start pulling the vices off the tables. We show them how to prep a table to load a vice. And so from day one through the rest of the semester, I lay it out where if that student is staying on task, they can be on a machine every single class. We do have, there's 9 Haas VF1. So a VF1 is a 3-axis milling machine, weighs about 7,800 pounds. It's an industrial grade machine, and our max capacity is 18 students. So in the beginning, if a class is full, it's about 2 people per machine. But usually someone's slacking where they're catching up on CAM or CAD, which we have computers in our lab. And the other person, if they're prepared, they can hop around that machine. And students will kind of drop, just it's the nature of it. I've seen is, so usually it goes down to about 13 to 15 people for a class. And then we also have other machines. And when I have students I'm comfortable with, I can say, hey, you can go on that more advanced machine. So to get back on track, yes, you're on the machine the very first day.
I mean, it's an awesome structure too. Like you're saying, it really caters to someone who has a job. You know, they can access that information on Canvas. They can do all of the preparation work, and as long as you're doing that, you're going to let them have fun, which I think is a great way to keep someone engaged. So much of this is, how do you keep that student from that first week to the last week, because that's, I took classes at Sierra. Attrition is a real factor, and then you can't address that better than giving someone what they're looking to do day one. So that's just awesome to hear. Now, I want to pause and talk a little bit. You mentioned Haas machines, and that you have 5 of this particular one. The program is also affiliated with the larger Haas Automation. Can we talk a little bit about who they are, what their affiliation with you guys is, and how cool it is that you have that sort of relationship?
Okay. So we have it's like 9, 10, 11, 12, 13. We have about 14 Haas machines. So it's 9 Haas VF1s, 2 5-axis UMC 750s, 1 ST10 lathe, 1 tool room lathe, and a VF2 SS. But so I wasn't there. I wasn't part of it. Actually, Bill Wenzel had a huge part to do with it. So he was a former department chair of welding. There is also Dan Frank. He worked at Rockland High. He's now at UC Davis. He had a big part of it. Even Tim Paul at Autodesk. They all joined together to help get this program going. And I know there's a lot of people I'm probably missing, but I know there are big players in this. So before I was hired, because I was just a part-time on the welding side, and so they were the big they're the big people behind getting this equipment in there. And then Haas also gave the school a $300,000 grant. So from my knowledge, the school paid for the machines, and they got a grant as a Gene Haas Foundation. So they'll give this to other schools. I didn't apply for it, so someone in the biz tech admin office had to apply for it and go through that whole process. But they were given a $300,000 award from Gene Haas, and Haas is awesome. They're American-made machines. Their headquarters is in Oxnard, California. And in fact, this is how cool they are. So I don't get money from Haas. I don't get anything from Haas, so I'm not a salesman or anything. But I was working my former auditing job, and I had to travel to Southern California like all the time. And so I was down there, and I was near Oxnard. I was like, you know what? I'm just going to go down there and check out the Haas factory. I go in there. I'm like, hey, I'm an instructor at Sierra College. Is there any way like I could check this out? Sure enough, 10 minutes later, they have, I don't know his name anymore because this is like 4 years ago now. They gave me a one-on-one tour going around the factory. It was like 30, 45 minutes. Just super cool. They're showing me their yard, where they keep their castings, where stuff's machined. And so they walked me around that whole plant, and Haas puts on, they're called H Tech events, and I think it's Haas training, it's something like that. So they'll go all throughout the country, and they put on these programs for educators, and they'll get input. So during COVID, they're like, hey, put together videos and we can put it, and so everyone can like look at it. And then they give you like they'll give your school vouchers for participating. Like they're really cool. They're super supportive of the education environment, and for the money, you cannot get a better machine. And they're used widely in industry.
I mean, I'm just blown away that you just show up. Like you didn't email, you didn't call. You're like, look on Google Maps. Oh, it's down the road from my hotel, and then they give you the tour. So that's just awesome. And it also really hammers home the fact that when you train on these machines at Sierra, you're not training on 20-year-old hand-me-downs. You're going to be training on what is industry standard, correct?
Yes. Yes.
That's again just so cool. How many relationships Sierra's really cultivated. You know, the cybersecurity program has some Pentagon endorsement. You guys have this relationship with us, so it's so cool to see at what level you can really learn the material just down the hill. And you know, when we were setting this up and I was talking to various deans, they're like, "Oh, people are going to have to go down to Rockland for this." And I'm like, Nevada County is used to driving to everywhere. You know, it's like, oh, it's in Rockland. That's close. So all of this is at your fingertips. So that's that blew my mind more than I was expecting to. Pretty cool.
Yeah. Do you one? And then I just want to do one more kind of the software we use. So again, I don't get anything from any of these companies, but I'm just blown away by the support. So Autodesk, they make Fusion 360, and that software, if you're a student, it's free. So in my classes, I try to provide everything online, so you're not paying any materials. And Autodesk, there's people local. I ride dirt bikes with Tim Paul. We haven't done it a ton, but we've been meaning to. And so he works with Autodesk, and then we have I think it's Gen D. So they'll come to advisory meetings. They're super active in what they're doing in education. So they work directly for Autodesk. So if I'm having an issue, I try not to overuse my welcome. So it's very rare. But if like something's going on with the software, I'd be like, hey, what's going on with this? I get a response within like 5 minutes. So it's just really cool to have that support locally. And so they're a big part of it.
I mean, having that support, having that relationship, like I remember, this is going to date me, about 20 years ago using CAD auto, like the early CAD programs that ran on, it was still, you know, green and white interface. This might be more like 25 years ago. And I never would have thought that a company of that level, like they've been doing this thing for decades, would have that sort of educational relationship and approach. It's really encouraging.
Mhm.
Now, you're a student, you've signed up, you did your first week of homework, you got to come in and play with that machine, get your hands dirty, really, from that first week, understand what you'll be doing. Now it's week 2. You're looking at the syllabus, you're looking at, okay, what am I going to have to do to get through this class and thrive? So what sort of study skills, what sort of, you know, things have you found help students really stick in there and get the most they can out of the class throughout the course of the semester?
Okay. So in Canvas, I'll kind of post what they're supposed to complete for the week. And then so they'll come in and then they'll start working on it. And then I also post kind of a lab objective of what we're doing. And so they kind of week by week, I give them their information. So in my syllabus, I don't have everything listed out what we're doing for the semester because there's not a bunch of curriculum you can grab for this. So I'm constantly changing, tweaking, trying to make my classes better. My entry level ones I have penciled out pretty well where I haven't had to make too many changes over the past let's say 6 months, but the software updates so frequently, you got to make update videos and so much so forth. But they'll come in, they'll see what's expected that week, they'll have due dates. And I try to, I try not to do just right off the bat hardcore machining. I try to make it more appealing to a broader audience. So I try to do fun things. I try to have parts that are relatable to the real world. So their very first project when they're loading a tool, like this isn't really a part, but they're just like when they're learning how to run the program, they're running a program that makes like the Sierra College S. And then the next machining one is we make a coaster. So like it's not a completely useless widget, but they make a coaster, they inspect it, and then we go on, we make this, it's like a connecting rod bottle opener. And later, if you want me to, I can show images of it. But I try to really make kind of fun projects that they do and relatable projects to keep them engaged. And then when we get into more advanced classes, I do the more if you're nerds like us, it's fun. But if you're kind of the outside looking in, more boring, but more of how to use that host control and comp in parts, just using the control and stuff like that.
I mean, that's the sort of thing that, you know, even if it's dry in the moment, that's what the employer is going to rely on you knowing, really having that comfort level with working with the machines. It's like
Mhm.
you didn't come out of lab touching it, you know, touching it once a week. You came out of lab making stuff,
Mhm.
which I think is cool. This could be actually a cool time to pull up some of those pictures of maybe the Instagram of some of those projects could be cool to see. So,
Okay.
see some
Well,
of the things that people have made.
let's see if I don't. All right. Can you see?
Yeah. All
This
right.
is this is a Sierra. I run this page, so it may or may not be kosher with the school, but um, I haven't been on it too frequently because like I try to kind of draw the line. I for the first 2 years I went so hard at this, and now I'm like, all right, I gotta draw a line so I can keep some sanity. But right now, so these are some student final projects that I've posted on here, of different levels, different classes. These are some student projects. This is a phone case. This thing actually came out really, really cool.
Whoa.
He finished it, and it was amazing. And this student, he was an engineering student. He's now going to Cal Poly San Luis. Like, we get a wide variety. We get college level students, we get retired engineers. There's all over the place. And right here, this is one of our projects on a, if I can click on it, this is on our 5th access machine. So like, we get a wide range of students. So that's a multi-access project. Here's another project we do. This is using a collet block. So this is kind of an intro into multi-access machining, but on a 3-access mill. So they're indexing this part on a 3-access mill. And then we do thread milling here. This is a picture of the lab right in here. This is part of the lab right here. And sorry, my computer's been a little laggy. And I've been trying to post jobs on here as well when people come into my lab and they're like, hey, we're hiring. We did a tour. This is AB Tools. And so they brought, we arranged, I forget, it was probably 10-ish people. So they gave us like an hour-long tour. It was super cool. Really recommend AB Tools in Lincoln, California. Dim Tech, they're I think Cameron Park, they came in. This is our lathe. These are one of our projects. So I have all the prints for the projects, and I do a bunch of different learning outcomes based on the project. So they'll machine it, they'll figure out how to clamp it on the back side, make soft jaws. So this is all student work right here based off my directions. Wow. And you can, when you want me to shut up, you just tell me and I'll stop screen share. And this is like a pop quiz. I do a pop machining quiz. And so this is a student doing the pop machining quiz, and they have to work. So there's a lot of industry. We have to do what the industry wants. We have advisory meetings once a semester. So they recommend group projects and working projects that go together. So I'll group them. They'll make parts that have to fit together with certain tolerances. And these are just more projects and my dog in the lab. And this is I'm making videos, new videos for this. This is a part of a speed wrench, so it's like a machinist tool. This is at the end of our level 1 class. So all those ones I clicked on are on the level 1 class where you can have 0 experience and start machining. This is a student in the sheet metal class. He did this. It's a you put like a turkey on there. I guess you put
awesome.
a root beer can in there, and then you put the glasses on it when you cook it. And he made so there's a
this is just an awesome glance at I think we're gonna get out of the Instagram world here, but that was a cool rabbit hole to go down to and really see. So you said that was all first level, like they come in first day of class, that was the project they did for the end of the semester, or?
Yeah, the one, so there's a coaster one, I don't think I clicked on it, but the speed handle one is yeah, they get down, and I don't have it right in front of me, but they're machining. By week 4, they're actually running their own programs. The first few weeks, we're teaching them the basics, like what's coolant, what's it do, how to take care of the coolant, how to use a refractometer, how to check your weigh lube level, kind of like typical maintenance procedures, safety procedures, how to safely run a program, how to properly load tools. And then how to safely run one of my programs using a Sharpie before we go breaking tools. Because one broken tool is basically, there goes $100 depending. So then by week 4, they should be running their own program, cutting metal on their part that they programmed and everything.
That's a pretty wild pace. And I can't think of anything that's going to retain students' attention more than cutting to the chase. So that's awesome. So that's a pretty rapid start to the class. I was expecting to be like, oh, we do all this, and it's like, no, just jump right in. Now we saw a lot of pictures of projects of labs of class, but we haven't talked too much about the computer side, the program side. And I know you had the program, one of the programs that you guys use open down there. I'd love to just take a look at what does it look like to design something from the digital side.
Cool. Are you good?
Yeah.
Okay. So this is right now, I'm currently recording new videos. So this is it's a speed wrench. So it's a machinist tool. Of course, mine's in my garage right now. But I go through, I provide prints, and actually, let's see. So I provide them with prints, and I provide them, it's loading, and hopefully my computer doesn't crash.
I'm assuming this is about as resource intensive as, like, say, ArcGIS, which always made my computer unhappy.
It might not be that bad because it's cloud based, so all this is like stored on the cloud, so it's not as bad as your traditional stuff that's saved to the local drive.
Okay.
But so I'll give them a print, and I have videos that utilize my print on how to create the model. And so once they create the model, that's just a 3D solid model, then we have to go through and we have to specify what size aluminum stock am I starting with. So they'll get just raw stock. This isn't the correct size, but they'll just get raw stock, and it'll be cut to a certain length. And so you'll buy this at a local metal supplier or whatever. It's extruded 6061. So we'll go ahead, we'll set it up. That yellow box represents the stock. And then the real important thing is where we set our 0, 0 point, which is our work coordinate system for X0, Y0, Z0. This dictates how we touch that work piece off. So videos that should go over how to set this up. And then we also have our tool library. It's all cloud-based. So these are the actual cutting tools that are on our machines at class. And there's a whole cloud library with feeds and speeds. So if we're doing like this first little pass, that's a skim pass. And if I right click on it, we go through and we determine how fast, what RPM it spins at, what linear feed rate it spins at, what geometry I'm doing, what are my step overs, pass extension, how I want it to enter the material. And so I'll walk you through those parameters one by one. So the next one's a drilling operation, next one's adaptive roughing. And so each one, like each piece of geometry has to be determined how it's machined, and that's up to us to do that. So you'll go through, you'll machine this whole top side. So now we have the whole, like, kind of the part is machined, but we have this weird, it's called a hat, this extra material on the back, and that's right now it's about 345 thousandths because we started out with 1 inch thick, my part's 625 thick. So then we've got to figure out how we're going to hold it. So we'll actually, create soft jaws. So they'll learn how to use the part geometry, project a sketch onto jaws that they make, and they'll create these jaws, and these jaws get bolted to a standard Kurt vise in our lab, and then they actually clamp the part. So now the part has been flipped over. And just before this video, I was working on the video for how to remove the back side of this. So now we come through, I'm doing an adaptive, and then we face it down to our nominal size. And for this project, mind you, we're going on to week 12 now. So I'm leaving it a little open-ended for our students to figure out how to clear out this web and pocket and chamfer. And this is kind of the first time in this class that I'm doing it, because we've had a lot of instruction and they have a lot of prior resources to do it. So that's one of the projects, and I'll stop my screen share.
That's pretty cool. So this is all the sort of preparatory work that the student would be doing before lab, correct?
Correct.
They'd be watching the video of you showing how to do it, then going through and writing their own program, basically, or?
Correct. So those tool paths I was showing you, those are kind of like if you have a Microsoft Word and you're creating a text file, it's doing a lot of stuff behind the scenes. So that's what that is doing right here. And then it's called post-process, and that creates a G code. So it spits out our G and M codes, and that is what we transfer to our machines. But this is not getting right into doing hand code. So there are people that will do, right now I try to keep it interesting, and a lot of people just get turned off if it's just a bunch of hand code. And the thing with hand code is, if you're on a machine typing in hand code, you can't like easily simulate it like you can in this environment. It's just not the same. So here, with using CAM, computer aided manufacturing, you can verify your tool paths and do a really good job of making sure you're not going to have accidents. And then with a complex tool path, it's basically impossible to hand code it. There's just thousands and thousands of lines of code. And back in the day, sorry.
That's really what fascinates me so much about this tech. It's what you're capable of manufacturing using this is just so much more refined than I hesitate to say that can be made actually by hand, but like you said, hand code plugging into the machines without this modeling is just next to impossible. This is the tech in the manufacturing that I just love.
Yeah. And to even kind of make your point, so this is like something I make, this is totally different. I have a machine in my garage, but even like adding tool paths like that on there that's not something they would do in the past. In the past, it's like make this part. And now with the software technology and the machine technology in combination, it's exploded. And the accessibility to technology, thanks to companies like Autodesk Fusion 360, is now a student can get a year trial for free for their full blown software suite, and they can play with it. And so like the access, like 10 years ago, this was not an option. I was using some garbage software that was like free, or you had to pay thousands and thousands of dollars. So yeah, the technology has been instrumental in this explosion over the past 10 years.
So you mentioned that software is using the cloud to process the information. Does that mean it's relatively accessible for most laptop owners? Does it have to meet specific specifications, or can you kind of roll up with the Chromebook and still make it work?
I believe now you can use a Chromebook. So in the past, I know Chromebooks wouldn't work,
Oh
but
man,
I think now it works. If you go on, I don't have this memorized, so it's my bad, but if you go on Autodesk website for Fusion 360, it'll show you the minimum requirements. But to my knowledge, Chromebooks do work on it now, because I know a lot of high schools use Chromebooks.
I mean that's really making this not just accessible with the student rate for free, but making it so you can actually you don't have to go into debt to buy a computer to take this class. You know, you don't need to show up with the nicest MacBook Air or the nicest whatever the Windows one is now. You can bring your workhorse and it'll be okay, which I think is so key for accessibility.
Yeah.
I had to get a whole different computer to learn ArcGIS because it was so resource intensive, and to not have that barrier. Yeah, I'm looking at Autodesk Fusion 360 available on PC, Mac, and Chromebook. So if it'll run on Chromebook, it'll run on anything.
Mm-hmm. And even like it keeps sounding like I'm trying to plug them, but a lot of engineering software doesn't work on Mac. And so this actually does work on Mac, which is really cool.
Yeah. I had to buy a, not bare bones window machine to run ArcGIS because I needed to do ArcGIS for my degree.
Mhm.
That computer is still in a box somewhere. Haven't used it since.
Sweet.
It's like who needs a barely functional 10-year-old Lenovo? No one.
Yeah.
So this is again, all of this is it's just so accessible for students, and I think that's just so important. And again, if you're watching this and thinking, hey, I kind of want to learn to do this, you can. Sounds like you don't even need to do a whole bunch of money on computing. You don't have to do a whole lot of time at specific times in class. The videos and everything. It's the classic asynchronous, right? It's students
Yeah.
access it when they're ready, which
Mm-hmm.
really helps particularly folks who already have a day job, are dissatisfied with that day job and want a cooler day job. Because I think that's one of the things that you're bringing home with showing that part you made in your garage. This stuff is cool. It's not all abstract. It's at the end of the day, you're making something you can touch, that you can hold.
Mm-hmm.
And you're making it with a computer, which closes that loop of, so much of the digital world, particularly in the last couple of years, it's like, oh, it's all online. This brings it down to earth, which I think is awesome.
Mm-hmm.
So that gives a real good look at what is class going to look like. You're going to be doing your computer time on your own time. You're going to be coming to lab ready to go and having fun with machines. Now, you talked a little bit about when we were looking at the Instagram pictures, companies that came in that you visited. So what sort of jobs and positions have graduates gone on to hold? I know you mentioned some folks went on to get higher degrees, which is also an awesome, potential, but you come out of Sierra, you did this, you get the associate. What are your career options?
So there's a lot of options, and to be completely honest, people are looking for employees now, and I get employers all the time. So this is like one that I keep by my desk for people that are actively talking to me. So right here, here's Martin Sprocket. This one's for Davis. I was talking to them. Oopsie, sorry. And then we got, anyways, we've got a bunch of different, we got Siemens, they're looking for people. This one's a school one, this one's a school one. Shoot, I got too many school ones mixed in here. Haas, like they're always talking to us. They're not looking for people right now, but we've got a lot of employers looking for students, and they're always coming in. And there's Aero Metal, so now we're getting into the better one. So I just have a bunch of cards. And so the people that stay actively in contact with me, I try to guide students to them. I will say one of the hard parts is a lot of our students aren't actually, the bummer is, but they're also increasing their knowledge, but they're not looking to be machinists for a lot of them, because I'll get retired engineers, I'll get engineering students, and I'll even get some mech students, and like they love it, but their end goal isn't machining. But for the ones that are trying to get in there, like there's shops all over Placer, Rockland, Grass Valley. We even did an internship with GSS in, I don't know if it's called Grass Valley or Nevada City. Have you heard of them?
They their offices are on the ground floor of our old offices. We've now moved on. They're right
Okay.
there in pretty much the Seven Hills Business District of Nevada City. Real cool folks that do real cool stuff.
Mm-hmm.
So, I mean, they're almost the classic example, I think, of, oh, we can't find, enough people locally. It's like, well, you can go on down, learn from Franz at Sierra, and come back and work at GSS.
Yeah, they are really cool. I've toured that shop. We have 3 students working over. We started with this weird internship, and I say it's weird because how it was presented to us. And then, anyways, they ended up just hiring the students straight out. They're like, you know what, screw this, we'll just hire. Like they're super cool. We worked with them, and the students, it's 4 students now. It's 4 students. And that's a place where there's a lot of mobility to move up. And so a lot of machine shops, it's kind of that old, like you got to work here for 20 years and deburr for 5 years, and you move up to an operator. But like GSS is not like that. And they're more mech related, but now they're purchasing 5 students. 5 students. We have 5 students at GSS because they're purchasing a new equipment. So I signed off for a petition for a student to jump into my advanced class. I just forgot about him. But they're buying new equipment, so they don't have to send all their machine parts out locally. And there's another person, they do these really cool mold work for like old, like the White House, like really old buildings. So they'll do the castings. They do a lot of manual things, but I believe they do some CNC, and I've had a couple of their students as well. I currently know I have one. But there's like if someone wants a job, we can get them hired. It's just, where do you want to work? And I'll usually send out a list, and I'll say, research these, tell me which one are interesting to you. And I try to be upfront with a student and employer. So if a student is not a good, like, let's say there's a learning disability, or let's say the student is super good, on time, or like a smart aleck or something like that, I'll tell the employer, I'll be like, hey, this person's good, but you might have these issues. And same with an employer. If the employer is not good, I say, hey, to the student, like, you might be facing this issues at the employer. So I know people might be hating me for saying that, but I try to let the employer and student know what they're getting into and how to cope with it. Like, because pretty much anyone I recommend, I would let them work in my garage or work with my tools or whatever. Um, Gosh, well, now I sound like an evil person on record, but
Well, no, at the same time, you got to be honest with this. It's not, when you're dealing with machines that can be dangerous, that can be seriously hazardous to safety, you gotta be honest. There's no cutting corners with this stuff.
yeah, yeah,
Um,
and yeah, how to work with that individual. And I try to get to know the students on a one-on-one basis, so I know I typically know what works for them and what doesn't. And so I'm not trying to put them in an employer where they're just like, all right, 12, if they are not set out to do a 10-hour day right off the bat, I don't want to make that happen. So like, I'm not perfect. I definitely make mistakes. So I'm learning as I go along here, but yeah, I'm trying to do what's best for everyone.
well, the upshot of that is there are jobs. there are many, many jobs to be had in this field. And yeah, pretty much why I wanted to talk to you. We keep hearing from folks like GSS, from, you know, there's so many small scale manufacturers up in Grass Valley, Autometrics. There's just a bunch of folks out at the airport business park there that need folks with the skills you teach. So hopefully we'll send some more students down the hill to you here. We're getting close to the end of our time here. And I think I pretty much successfully hit most of the points I wanted to hit, which was, what's it going to look like when you first walk in? Fun, sounds like. What's it going to take to thrive and succeed? And really just wanted to hammer home the fact that it's possible to learn a whole new career at an institution real close to us on cutting edge tools with some really nice people. So any final thoughts you want to share with the folks out there, Franz?
I'll just say, and then kind of back to accessibility for our classes. Our classes are all, because we realize most people work or are busy during the day. So we do night classes. So they're typically at 4:30, like the core classes. They'll start at 4:30 p.m. and they're usually a 3-hour lab. And then this is for all classes at a community college. Is, from my understanding, if you take a full load and you meet a certain GPA, you get free tuition to community college. So that's something that's out there for students. And then even at our school, there's so many resources for students where if a student can't afford a computer or something like that, we have people at the school where we can link them up, and it's actually very easy to get them purchase their own personal computer. The library has computers. I tell all my students, hey, if you need to catch up or you have internet issues, you can come into my other labs and use our computer. We have more on order as well. But you do need access to a computer and internet for our classes. And we have really great programs. So we're right next door to building industries, welding, mechatronics. We're kind of all in the same area. And then right now, the whole building, within 2 years, it should be completely gutted, and we should have a new, it's going to look like a new building, because right now it's pretty old, but they're going to be ripping it down to the studs. They're going to kind of temporarily move us to another building and then move us back. So it's going to just hopefully keep growing. But we got to have student enrollment, or it's not going to grow. And I'll be bye-bye. I'll be out of a job.
I think that's as good a closing thought as any. Students, sign up, take these classes, get a good job, have fun doing what you do. Thanks so much for joining me tonight, Franz. It's really been a pleasure chatting with you. Real glad I finally got to highlight the advanced manufacturing program at Sierra College. Thanks again.
Yeah, and I don't try not to make anyone mad or offend anyone. So if I did, reach out to me and I'll apologize personally.
Well, this was a fun one.
It was good. Thank you so much for having me. I really appreciate it. Sorry about kind of the back and forth. But this was awesome. So feel free to reach out, anyone watching this. I check emails.